Okay, here we're going to do question number 4, which is on page 20 of the Unit 2 review. So first we need to read through this and figure out there's a big space here, so we're going to need to draw a picture, which means it's either a Venn diagram or a tree diagram. So let's read carefully. Suppose that 46% of job postings on a career website require applicants to have a college degree, 65% of job postings require that an applicant have previous experience, and 30% of the job postings require both. They have a degree and experience in the field. Find the following. So they give me a probability of one event, a probability of another, and then most importantly, the probability of them both. So this is a Venn diagram where hopefully I can draw a nice picture for you. This is something that you did with the sub, but I did an example with you guys to solidify it, okay? So remember that we need to label these up. So somebody's got to have, some of these jobs require a degree, and some of the jobs require experience. And we know that 30% require both. So remember, we made this easier and we said assume there are 100 job postings. And if we do this, then we can make sure that all these are out of 100 total job postings, which means if 30% require both a degree and experience, and we're talking about 100 jobs total, then 30 of them would require both. So that would go in the middle. Now I jump to either side and I do a little bit of math. It says 46% require a degree. So that means I have to look at 46 and subtract the 30% that require both, and I'm left with the 16 that require just a degree. And then I do the same on the other side. 65% require experience, but 30 is both. So that leaves 35% here on the this particular experience only. And then for this outside number, I take the total and I subtract the other values that I've already put inside the diagram. So I add up these three numbers and subtract them from 100. And this total is 81. So when I subtract that from 100, I get 19. Now, if this says the probability that a random posting, blah, 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 then every answer is going to be out of 100 until they tell me given. So down here, when I see the word given, I know I'm going to have a smaller denominator, but not until then. So let's read carefully. The probability a job posting requires a degree or experience in the field. So the word or is addition. So degree or experience. So I'm going to take all of the possibilities. I either only have a degree, or I have a degree and experience, or I have just experience. So the 16 is people who just have a degree. The 30 is people who have both. And the 35 is the people who have just experience. All out of 100. So this means that this is 0.81 or 81 out of 100. So let's go to B. This is going to be the probability that a random job posting requires no degree and no experience. So that would be the probability there's no degree required and no experience. So that's a no on the E as well, okay? So that means my dog is here trying to get some loving from me, okay? So this means that we can't be inside the degree circle and we can't be inside the experience circle. So the only number outside is the 19 out of 100 people who don't have either a degree or experience. So this is going to be 0.19. This question is tricky. Find the probability that a random job posting requires a college degree but no experience. So this is worded strangely. So they want a degree and no experience. So when I look up at my diagram, I did this in class and I can't do it on this video that I'm aware of. But I would actually cover up the entire experience circle. So what I would do is I would look at the degree circle and then cover up where the overlap is and look at what else is remaining, which means there are 16 out of 100 people, or a probability of 0.16, that this job requires a degree but no experience. This is the same as the probability of a degree only. So I'm looking only in the degree circle, not where the overlap is. Part D says, find the probability a random job posting requires a degree given it requires experience. So that looks like this. The probability it requires a degree given it requires experience. Now, that formula has the probability of both in the numerator. So that's a degree and experience divided by the probability that the job requires experience. So degree and experience is the literal overlap in this picture, and that's the number 30. Now we get tripped up when we talk about experience. Be careful. There are 35 people who have experience only, but 30 who actually have a degree and experience. So this is equal to 30 over 65, which I just realized in my solutions is incorrect, which equals, it says 30 over 46, but that's actually the answer. It equals approximately 0.46, okay? So there's just a little typo in my solutions, and I really apologize for that. Part E says, are the events requiring a degree and requiring experience independent? Okay, so two events are independent if we can show that the probability of A given B is equal to the probability of A. What this means is B has absolutely no impact on A. So it doesn't matter that B happened first. It's still, these numbers are still equivalent. So this says requiring a degree and requiring experience, are they independent? Well, the easiest way to check this is to use a given statement like we see here. So look at what we've already shown. We've already done in part D, right? We showed the probability that a degree given having experience is 30 over 65. Actually, I'm going to get rid of the fraction. Sorry, guys. We already showed this value, 30 over 65, degree given experience, in part D. In order to show independence, we would have to question, right, whether or not, that's a question mark over top my equals, this is equal to the probability of, and then I'm looking at this as A given B. Remember that the probability of A given B is equal to the probability of A if they are independent. So this would have to be equal to the probability that someone just has a degree. One of my dogs is playing with a toy, so I apologize for that. Now, I'm going to move to the right-hand side because I'm running out of room on my screen. But degree given experience is 30 over 65. The question is that the same as just a degree? Now look at the entire degree circle, or go back up to the original paragraph. It said 46 out of 100 have a degree. So, or 46%. So these two are equivalent because part D was equal to 0.46 as well. So these events are independent. Okay? Because these two things are equal. Let me write it at the bottom. 0.46 is equal to 0.46. Okay? Sorry, my handwriting's so bad at the bottom of the screen there. Okay?